Okay, so today we're going to look at question number 8. 8A is going to be the same thing every single time. It's going to look complex at first, but I guarantee you it's a free 12-mark question always. Okay, so the question is basically about associations and relationships, correlations. To make it simple, what we're essentially going to be looking at is, say there's a table of male, female, whether they play sports or don't play sports, and we have certain numbers. Okay, so we have, out of the males, 90 of them play sports, 10 don't. Out of the females, 30 play sports and 70 don't. This is turning out to be a bit of a sexist example, so I'm just going to switch around the numbers. Okay, 90 females play sports, 10 don't. 30 males play sports and 70 don't. Okay, so we're going to be given a table like this, and what we're basically looking at is there an association between gender and sport, or rather whether or not they play sports. So from just looking at it, it's pretty obvious there is an association, because it looks like if you're a female, you're more likely to play sports, and if you're a male, you're much less likely to play sports. So this is just, in essence, what we're going to be doing in this question. So the first part is always going to be just looking at the table and trying to say if you think this is an association or not. And then the second one is we're going to statistically prove that there is in fact an association, or there is in fact not an association. So we're looking for evidence. Before you get into the second bit, which carries most of the marks, let's just quickly try to do an actual example here. So okay, so we're looking at the connection of the association between mobile phone brands and their primary reason for switching. Okay, so we got brand A, B, C, and 3 different reasons. Let's just look at it. This is question 1. Based on the data, without conducting any tests, would you say there is an association or not? Okay, so let's just look at the data. Brand A, looks like most people switch due to customer service. For brand B, a lot of people switch due to customer service as well. But for brand C, it appears to be more about price and reliability. More specifically, another thing we can notice is reliability is really a small concern for people from brand B. Customer service is a really small concern for people from brand C. And it seems pretty clear there is some differences. Based on what brand of phone you are using, it appears you're likely to have different reasons from just looking at the numbers. So we don't need to do a lot of work here. We can just say, okay, price appears more of a concern for people from brand C. Customer service looks to be more of a concern for people from brand B. People from brand B don't care about reliability. Don't have issues with the reliability often. C don't have issues with customer service often. A is a bit mixed. The CVP fairly spread. So based on this, we can say we think there may be an association. We cannot say there is, because we haven't done any tests. And we always conclude with need to investigate further, which is what we're going to be doing in part B or part 2. So yeah, this is textbook. You just look at the numbers, you see if there seems to be any difference across the different type of people or different brands based on just what the example is. You'll most likely you'll find some sort of association. If you don't, just point that out, but at the end always say there may or may not be. Like if you think there is, there may. If it's not, there may not, but always say we need to investigate further, and that'll give you like probably 3 marks from this, I think. Okay, now moving on to actually investigating and trying to figure out if there's an association or not. Now it's going to look a bit complex, but like I said before, it's textbook. You're going to do it every single time. When doing this, let's have a small checklist of things we need to go through. Firstly, every time we see test for something, it means we are doing a hypothesis test. Hypothesis test, I'm not sure if we've done this before, but it's basically you set out a hypothesis, you set out an alternative hypothesis, which is often H1, and you test whether your H0 is true. In other words, it's always going to be this. In H1, you're going to say H0, you're going to say there is no association between X and Y. In our case, X is going to be, we're just going to write down brand and the reason for switching. And your H1 is going to be the direct opposite of this. So there is a association between brand and a reason for switching. Remember, always your H0 is going to be there is no association, there is no relationship, there's no whatever. Your H1 is going to be the opposite. And the way hypothesis tests work is basically we're trying to find evidence to reject H0. And if we reject this claim, if we reject the claim that there is no association, that automatically means that there is an association and our H1 is true. But statistics is very finicky, very specific, so we never ever say our H1 is true. All we ever say is H0 has been rejected, and there appears to be evidence. There is significant evidence to reject H0. That automatically implies that our H1 is true, but you don't need to write it out. Probably I would recommend not writing it out. Okay. So yeah, notes never say H1 is true. You're probably going to say something like, we have found evidence that there appears to be an association between brand and switching reason. Something like this. This is just textbook. Always remember this. So the first part of our checklist, we are always going to start with our hypothesis. We are going to write down our H0, no association between X and Y. H1, there is an association between X and Y. Okay. Once we do this, now we actually have to do some math, some calculations. The next step is going to be to calculate what we call the expected value. Now, do not confuse this with our expectation function, the E of X, E of Y. It is similar, but for now, just forget about it when dealing with this question. Just think about it mechanically and just follow the steps I'm about to give you. Okay, let's move on to another page. Oops. Okay, so there we go. So again, step 1, H0 and H1, we write that down. Step 2, we are going to create an expected values table. Okay, just take this table that we have over here and just write down the very shorthand version of the columns and the rows. So I'm just going to go A, B, C, price, reliability, customer service. Okay, now okay, so we're going to fill in all these cells. I'm going to tell you how. Let's focus on filling in cell number 1, which is the expected value that's supposed to be here. Okay, so for brand A and price being the reason, what we're going to do is we're just going to look at this cell. So from this cell we're just going to go all the way down to the total column. So you got 104. Let's write 104 down there, and then we're going to go across to the total column. We got 100 into 100. We multiply them, and then the whole thing we divide by the total. So 300. This will give us 34.66. For the next cell, we're just going to look down at the total. The total in this reliability column is going to be 95. Then from here, we're going to look across to the total for brand A, which is 100 divided by the total 300. This is going to be, let me just put it in my calculator, 95 into 100 divided by 300, 31.667. Oops. Don't round off here, by the way. And for this one, it's going to be same, 101, 100, 101 into 100 divided by 300. That's going to be 33.667. Okay, now in this question we're quite lucky because you see these numbers don't really change, so it's going to be the same for each column. I mean, you can see why. It's going to be 104. For this, it's going to be 104 into 100 divided by 300. Again, same for this. It's going to be 104 into 100 by 300. Now, if this number was like 34, it's going to change. But since we have just hundreds here, it's spread evenly. It's going to be the same value for each column. So it's going to be 34.667, 34.667. Okay, so this is one of the biggest steps, calculating the expected values table. But it's very simple. Just make sure you don't get you don't input the wrong number, you don't mess up your arithmetic. Just do it slowly, take your time, because we are only focusing on a few questions. So take your time with this. Always look at the cell, look down at the total, look across at the total, divided by the total. Repeat for every single cell, write it down in a table like this, and step 2 is done. Okay. Step 3. We are going to compute what we call the test statistic. Now, what is this test statistic? The test statistic, in very simple words, just the amount we need to understand for now, is a number that tells us whether or not to reject H naught. I remember the whole reason we're doing this whole test is to reject H naught, and H naught says there is no association. So if we get a large enough number, that means we're going to reject H naught. If the magnitude of a number is big, just means we can reject H naught. Now, you need to remember just one formula. This entire question is based on just one formula. I'm going to write it down here. Again, going to look complex, but it really is not. Okay. Sorry, this is summation of the whole thing. Okay, let's just go step by step. EIJ just means the expected values that we computed. So we already know what EIJ is, we just calculated it. So for each cell, the EIJ is what we calculated here. OIJ is the observed value, not the expected value, the observed value. So for each cell, the OIJ is what we have here. So OIJ is what is given in the question, EIJ is what we work out in step 2 in our expected values table. All we're doing is for each cell, we're taking the observed value, we're subtracting the expected value that we created, we square it and divide it by the expected value. And once we do it for each cell, we're just adding it all up. So again, you're going to have to do it in a calculator. It might take a while, but it's very simple. Let's try and do it for the first cell. So our observed value is 23. 23 minus 34.66 squared divided by 34.66. Now we have summation. IJ basically means for every column, every row. So don't worry about it. So since we have the summation, we're going to go to the next cell. 35 minus 34.66 squared divided by 34.66. Next one, 46 minus 34.66 squared 34.66 plus, like I'm just adding up, and you're going to repeat it for every cell. So here is going to be 37 minus 31.667 squared. I mean, I forgot to add 7 here, sorry. Just 667 plus 16 minus 31.667. This is why I said it's really easy to make a table, because you're going to go, when you do it, yeah, just to make sure you're not going to make any mistakes, circle it, circle it. Once you're done with it, circle it, circle it. And we're over here now. The next one. Now you're gonna need to be proficient with your calculator if you want to do it all at once. But I recommend, since we have so much time, just calculate the values separately, do it for every single cell, and then add them up in another step. So here, I'm sure you got this by now. 40 minus 40 over here, minus 33.667 divided by 83.667. Don't forget the square. And yeah, the same goes here. Okay, when we add up this number, do this, work it all out, we are gonna get, remember this is the test statistic, right? So we're just gonna write t stat is equal to 41.774. Okay, so we got a t statistic. How do we know if it's big enough? How do we know if this number is big enough to reject H naught and to conclude that there is an association? So to do this, we need to understand, do we need to get into that? Just thinking, sorry. Actually, I'll be right back. Okay, so again, we need to know if our t-stat is large enough for us to reject the H naught, reject the claim that there is no association. In other words, find evidence for an association. Okay, to do this, we're going to rely on something called the critical value. And the critical value in turn is found using two other things called the significance level and the degrees of freedom. Now, let's not worry too much about this for now. I'll just explain how these two link together. Okay, let's start with the significance level. In statistics, we usually use 3 levels of significance: 10%, 5%, and 1%. What do these percentages mean? Basically, in very, very, very simple terms, may not be the right statistical definition, but you can probably Google that up. At a 10% significance level, there is a 10% chance that your results are wrong. At a 5%, it's a 5% chance that your results are wrong. 1% chance that your results are wrong. So obviously we want to go for the lower significance level. If the significance is really low, it means you have a really strong result. What do I mean by results being wrong? Now, we've had this example before. Let's just go back to it. We have a whole population of people. Let's say we're looking at the mean weight. So the true mean weight mu. Obviously we can't obviously we can't study all of them, so we're going to take a sample and we're going to compute a certain mean weight x bar. Now when we do a test, we're basically saying if x bar is going to be the true mu weight. If you're doing it at the 10% significance level, there's going to be a chance that our test tells us that x bar is in fact the true mean weight, but it is wrong. So there's a 10% chance of us being wrong. If you do it at the 1% level, there's only a 1% chance of us being wrong. So basically, let's not get too much into the actual mechanics of it. For now, just think of it as the percentage of you, the chance of you being wrong. The lower the better, but obviously it's going to be harder to get the lower significance level. And I'll explain why. So right now we discussed how to do a test. We're going to find a t-stat and to use the t-stat to reject our H naught and figure out if our claim that there is an association is true. We use something called critical value, and that depends on the significance level. Okay, so think about it. If our critical value was 2, it's going to be very, very, very easy for us to reject H0, because to get a T-stat of 41, I mean, we got a T-stat of 41, so we're obviously going to reject it. So we're trying to go for as high of a T-stat as possible. Every time we do a test, we hope to get a high T-stat so that we can reject H0. And basically how the rejection works is, we reject H0 if our T-stat, the absolute value of a T-stat, so regardless of whether it's -4 or 4, is greater than our critical value. So we want to reject H0, and to do that we need this to be true. So obviously we want to get as high of a T-stat as possible and as low of a critical value as possible, so that it's going to be easier for us to reject. Linking back to significance levels, basically how it works is, at a higher significance level, your critical value is going to be larger. So for example, for a standard test, if you use a 1% significance level, your critical value is going to be 2.56. If you use a 5% significance level, it's going to be 1.96. At the 10% is going to be 1.64. You don't need to know these numbers. I just used them a while ago, so I remember them. So as you can see, at higher, so because think about it, you do a test, you get a number from like 3, or like from ranging from 1 to 4. It's going to be much easier for you to reject with a higher significance level, because at 10% you're going to get a lower critical value, making it easier for you to reject it. So yeah, that's basically how they link together. I'm sorry if it was a bit confusing, but it will make sense when you do an example. And again, you don't need to know this intuition. Let me just clean all this up. Oops. Okay, so we got a T-stat. Like I said, we need to find a critical value. To do that, we need a significance level. In ST107, we always start at the 5% level, and then from there we go to the 10% or 1% level based on whether we reject H0 or not. So I'll show you. Let's just keep this as 5% for now. So we have a significance level. What is the degree of freedom? The degree of freedom is a number you're going to calculate, and it's very simple to do. All you do is R minus 1, C minus 1. What's R, what's C? R is the number of rows you have. Which ones are the rows again? Yeah, okay. I have an issue with rows and columns. Okay, let's see. Alright, R is the number of rows you have, and C is the number of columns you have. So we have 3 rows, 3 columns. Go down. 3 minus 1, 3 minus 1, that's 2 into 2, 4. Okay, our degrees of freedom is 4. Don't worry about this, it's very simple. Just calculate the degrees of freedom by just subtracting the rows minus 1 and the columns minus 1, and you'll get your degrees of freedom. Okay, so we have 5% significance level. You got your 4 degrees of freedom. What the hell am I supposed to do with this now? How do I find my critical value? In your handout, you're going to get a bunch of tables, and I think in the 4th or 5th page you're going to have your table 8. This is the table we're going to use for our question, Again, easy way of remembering it, you're gonna you're doing question 8 and you need to use table 8. Okay, now how do we find our critical value? Okay, all we need to do is go to the table. Oh, I forgot to copy the other part of the table. Just a second. Sorry, I just forgot to copy the second part of the table. So table 8 has two parts. It's going to be the first page and the second page, which is just continued. We always use the second page for this question, so just keep that in mind. Now, what information do we have? We have information that our degrees of freedom is 4, and we are gonna always start at the 5% significance level. Okay, to find your critical value, you're gonna just look at these numbers first. We start at the 5% level, and that is this. Remember, 0.05 is 5%. Okay, we got a 5% values. We got this whole row here. Now we look over here. These are the degrees of freedom. V is the degrees of freedom. We have 4, so we just 9.488. Okay, so our critical value is 9.488. Now let's go back. We write at 5% sig level and 4 degrees of freedom, crit value is 9.488. T stat, which you calculated, is 41.744. Sorry, 774. Since 41.774 greater than 9.488, we reject H naught at 5% sig level. Just remember to write that 5% level. Okay, now you remember I said we do this first, so there is a second step. If you reject at 5, you go to 1%. If you don't reject, if you fail to reject, you go to the 10%. Basically, it's harder to reject, like I said, it's harder to reject at lower levels of significance. So we try 5 as a midpoint. If we reject it there, we go further down to see if we can also do it at the 1% level. If not, if you fail to reject, we make it easier to reject and try the 10% level. Since we rejected, let's go to the 1% level. Now again, it's going to be the same degrees of freedom. We're looking at 1%, so 0.01. That gives us 13.277. We just write the same thing at 1%. For DOF, the crit value is 13.277, smaller than 41 point blah blah blah. So we reject it at 1% as well. And when we reject it at 1%, we say there is strong evidence. I'm running out of space, right? Okay, I'll just say that there is strong evidence of an association between X and Y, which is brand and primary reason for switching. Okay, so that's basically how we do the first part of question 8A. It's going to be 12 marks every time, and if you get this down, you're going to get 12 marks every time. So I'll just recap. Maybe down here, just copy the question. Step 1, write down H0, H1. H0 is always going to be there is no association. H1 is going to be there is an association. Step 2, work out the expected values, which again, you go to a cell, find the total, multiply it by the total, divide by the total, do it for every single cell. Step 3 is calculating the T stat. The formula, don't forget to write it down. just going to be OIJ minus EIJ, the whole square divided by EIJ. Like I said, when you do it, just write down every single, the summation just means add them up. So just do 23 minus what do we got there? I think 34.66 divided by 34.66. Square it, repeat it for every cell, add them all up. 4, find your critical value based on your degrees of freedom. Degrees of freedom is just going to be columns minus 1 into rows minus 1. Your significance level is always going to be 5% to start with. Then you go 1. If you fail, you're going to go to 10. If you succeed in rejecting it, you're going to go to 1. And then you go and find your critical value from the second page of table 8. You're always going to start at the 5% column unless they tell you to start elsewhere. Just look at your degrees of freedom, find the number, reject, move on to the 1% or the 10% as needed. And yeah, just remember to write at the end whether you found strong evidence. If you reject at 1%, you found strong evidence. If you reject only at 5%, you found moderate. If you reject only at 10%, i.e. you failed to reject here but you came to here and you were able to reject at 10, then be weak. If you fail to reject even at the 10% level, if your critical value at the 10% level is smaller than your test statistic, larger than your test statistic, then you just found no evidence. You do not reject H naught. Okay, so yeah, please try one of these questions. But yeah, it should be guaranteed 12 marks, I hope.